Hey everyone, welcome back to the shop. Today I'm going to be building my take on Abom79's tap driver project he did a while ago. Now if you don't know who Adam is or haven't seen this video of his, definitely check him out. I'll put the tap driver video up there and his channel link will be in the description down below. So basically I have this hole I need to tap. It's in a piece of about 1/2 inch aluminum brass, which is a actually pretty tough alloy. It's not like a regular brass, and I'm just not looking forward to driving this tap all the way through by hand. So I thought I'd try my hand at Adam's tap driver project to see if I can make this work in my homemade mill. So what I'm starting with is this piece of 1/2 inch hex stock with a small hole drilled through it. Looks about 3/16 or so. But anyway, what I need to do is bore this piece of hex stock to the width of the shaft of the tap, which is, I believe, 9 millimeters. So I'll look around and see closest drill bit I have to 9 millimeters. Bore that hole for about an inch deep, and then for another about a 1/2 inch, I need to mill a slot in the top of this piece of hex, so the square at the end of the tap can slide really nicely into it, and I believe this square is 7 millimeters. So I need a 9 millimeter hole, up an inch of it, and then a 1/2 inch deep slot that's 7 millimeters wide. So first I think I'll start with the boring operation. So let's go see the closest drill that I have to 9 millimeters. Alright, so the closest bit I came up with was a 3/8 inch. I measured it, and 3/8 inch bits are 9.48 millimeters, so that will leave around a 0.24 millimeters of slop on each side of the tap. So that's actually a perfectly acceptable number for what we're doing here. So how I'm going to bore this is I have the work actually up in the chuck, so it's nice and centered, as you can see. It fits really good in there, and I have the drill lined up perpendicular with the vise, so it's straight up and down, and I also have it centered in the work. So what this is hopefully going to do is, to an extent, it should self-center a bit. I mean, it's like a lathe. This is basically a lathe operation we're doing here. Hopefully it will self-center a bit. This part's better centered. The alignment will just all be better, and we'll get like a straighter hole overall. So let's actually try this. I've never drilled like this before, so let's see if this works. Alright, so the boring operation's done. Turned out really nicely, just with a quick measure and calipers, and with my eyeballs, it's nice and centered, down to about 0.1 millimeters actually, from side to side. But anyway, next operation is to cut it to final size, because it's actually a bit too long. Like I said earlier, I want an inch of bore, which I now have, and a 1/2 inch of slot for the square. So obviously the part will be 1.5 inches long. So I'm gonna real quick cut that, and I'll also cut the video because you don't need to see that. But if we jump to right here, you can see we actually already have it cut. So now that it's 1.5 inches, all we need to do is the slotting operation. So let's plan that out real quick. The square we need cut in is, I think I said before, it's 7 millimeters. And again, I live in America, so I don't have metric cutting bits. So I'm gonna go dig through my end mill collection and see the closest thing I have to 7 millimeters. And if I don't have anything close, I'll obviously just go undersized, and then we can compensate and move back and forth to make the slot wider. So I'm gonna real quick look over there and see what we got. Alright, I've looked through my end mill collection, and closest thing I have is 1/4 inch. Now I'm gonna swap this whole conversion thing back to standard units, because this whole metric business is hurting my head. So let's just remeasure here. In inches, the square that I have is, I'll write that down, 0.276. Obviously a 1/4 inch end mill is 0.25. So if we want to, if our first pass we make through the material makes us a channel that's 0.25 inches, then we have this the difference of the two, which is 0.026 to make up. Like, that's the rest that we need to cut. So if we have 0.026 and we want to make that up in this, we want to keep the slot in the center, so we don't want to go 0.026 to one side or 0.026 to the other side. We want to go 0.013 on each side. So that's divided by 2, and then you get 0.013. So how this will work is we have our, oh, that's not good. We have our, I'll move that in the center too. We have our hex, and we're going to make our first pass, let's say, this way. So we get 0.25 millimeter cut, or inch cut, my bad, 0.25 inches. Our next step is we're going to move in this direction 0.013 inches. We're going to go back to our 0 mark, and then we're going to go in this direction 0.013 inches, and that will give us a slot which is 0.276 inches, which is the size of the square we have here. So if that hurt your head, then bear with me. I'll just skip to a time lapse of this all happening, and you won't have to endure this any longer. Alright, it's all done. Or it hasn't been cleaned up much yet, but all the operations have been done on it. As you saw, the slotting just got done, so now we have a nice place where the square can fit. That fits quite nicely, and the whole thing should just slide together like so. Beautiful. Alright, so now this can go up in the drill truck, and hopefully we can tap that hole. But yeah, that's pretty nice. I'm debating on whether or not to clean this thing up, just because it's probably gonna get scratched up a bunch anyways. So I think for now I'll just try it how it is, and we'll see if it works worth anything. And maybe later we'll clean it up, make it look pretty. But yeah, there's that. Alright guys, I'm actually gonna wrap this video up here. I tried to tap the piece of aluminum brass, and long story short, it didn't work. But it's definitely not this thing's fault. This is a great little tool, and it did what it was supposed to. The reason it didn't work, or this job didn't work for me, is because, alright, first I'm using a drill press. It doesn't have the torque to drive a 1/2 inch tap coarse threads through a 1/2 inch piece of what is equivalent actually to like a mild steel. It's just a really tough material to tap, and even I tried to finish it off by hand, and it was still just a really difficult thing to tap. In not smaller, but softer materials and maybe thinner materials, this works great. I tried it on a couple pieces of like 1/8 inch aluminum, that worked good. But yeah, this didn't work, but again, it's not the tapping head's fault. Overall, I would say it's a great little tool to have around. You could what I actually am probably gonna do is you can make a few of these, because it's a really versatile little thing. You can easily adapt the hole size and the square size to whatever size you need. So like I have this half-inch one. You could have one for a common like quarter 20 tap, maybe a couple metric ones for like an M3 M4 bolts. Just the most common ones you have. You can always have these laying around ready to go, so when you need them you can just throw them in the mill and you're ready to power tap. But yeah, it's a great little tool, little project. Knock it out in like an hour. Thanks to Adam at Abom79 for the idea, and I think I'll see you guys in the next video.